Hey guys, how's it going? This is Mr. Burley, and we are going to go today and look at energy flow through ecosystems. So if you guys look right here, we're going to be talking about the flow of energy from the sun and other chemical sources here through our autotrophs, which are producers, all the way to our heterotrophs, which are our consumers. We're going to talk about how energy is gained and lost and how it flows from ecosystem to ecosystem and organism to organism. Right? So the first thing when we're talking about energy flow, we need to know a little bit about the chemistry, the background behind thermodynamics. So the first thing you need to know is the first law of thermodynamics. And what this states is that energy is neither created nor destroyed. It is only transferred or transformed. So what that means is our energy that we get from our food, that we get from the sun, it's not going to disappear. It's only going to be changing forms, and it's only going to be transferring from one organism or one trophic level to another. So that's what we're going to be talking about today, how that happens and how this works, and look at some examples and kind of talk a little bit about how this works in a trophic structure. So when we're talking about energy flow, the first thing we need to talk about is productivity. So when you're measuring productivity, there are two different types of measures you want to use. The first one is GPP, which is gross primary production. Now what this is all the light energy or all the chemical energy, depending on the ecosystem you're in, converted to organic molecules per unit time. So typically this would be all of your biomass is produced in, say, a year by your producers in an ecosystem. And that's going to be just in total, all the energy is your gross primary production. Now, the second way you can measure this, and the more useful way to measure it, is through net primary production. And net primary production is only GPP minus the energy that those producers used to create the energy, and that was during respiration. So how you're going to calculate net primary production is just your gross primary minus the energy that those producers used for respiration. And that's going to give you your net primary production. That is the usable organic energy, the biomass there, that you're going to be able to use, that these organisms are going to be able to use in order to do their own processes and stay alive. Now, as we're talking about productivity, we're going to start talking about energy and how we produce this energy. How is it made? How do these producers kind of make all this energy up? And when we talk about that, we have to talk about how it's limited. So what we're going to be looking at are these things called limiting factors. And now a limiting factor, as the name implies, is a factor that limits the productivity of an ecosystem. And so these are factors, they can be abiotic or biotic, things like food, sunlight, nutrients, space. And they determine kind of how much productivity your ecosystem is going to have. Now, one thing to note is that there can only be one limiting factor at a time in an ecosystem. You're not going to say, there are 5 limiting factors. You're only going to choose one, and that's the major one. And if you add in that limiting factor, say for instance nutrients, and you don't have any nitrogen, for example, if you add in that nitrogen, you should see an increase and a rise in the productivity of your ecosystem if that is your limiting factor. So if you're going to test this experimentally, if you would add this supposed limiting factor back in, you should see an increase in the productivity of your ecosystem. If you don't see an increase, it's probably not your limiting factor. It's probably something else, and you need to keep testing. So some examples, like I said, things like food. Here, you guys know that you need food in order to grow, increase your own productivity. These other sorts of things, these can be for consumers, for the most part. Have a big one for our producers. We'll take a look at an example of that in a bit. And space. If you have all this room for activities, you can grow. But in some cases, it can be a little crowded, and that might be a problem for some organisms. So these types of things are examples. There are more than this. Don't just limit your limiting factors. But yeah, abiotic, biotic, and there are ways to test these. So let's take a quick look at an example of limiting factors in the ecosystem, how this affects the productivity of the ecosystem there. So if you guys think about a rainforest, And in the rainforest, there are tons and tons of trees. You have the canopy, and you have all these trees that are growing taller and taller in order to get to the sunlight there. And you get this kind of canopy. It's kind of like an umbrella where all these treetops are covering and taking up all the sunlight. So if you look at the forest floor of the rainforest, it's actually pretty shady, and there's not a lot of sunlight getting through. There's very little getting through. And so there's not a whole lot of productivity. There's way more here in terms of producer productivity in the canopy than on the forest floor. So you have to wonder, how are the organisms that live on that forest floor able to kind of get this energy? How are they able to live and keep making their own energy as consumers? So one way that organisms have kind of adapted to this challenge, the selective pressure, are these leafcutter ants here. And so what they do, their special adaptation, is to go, and there are hundreds and hundreds and thousands of these little guys that go out and they'll cut up these leaves, and they'll cut up leaves from these different parts, and they'll take them, they'll carry them down into their environment. So they go up to these trees, they take it from the other level, the other trophic level up there, the other level of the trees, and they bring that biomass, they bring that energy down to their level. So they've kind of found a way to steal from the other levels there. And they bring it back, they'll chew it up, they'll spit it out, do all this nasty stuff, so they can use that energy for their own. So this is kind of one example where you do have a limiting factor of sunlight here, and that sunlight as a limiting factor is decreasing the productivity on the forest floor. But the way that these organisms, in this case these leafcutter ants, have adapted is to go up and get some of that productivity, get their own share of it, and bring it down to their level. So they're kind of stealing a little bit of the productivity from the canopies here. So that's one interesting example of a limiting factor. There are also all sorts of other ones. Deep ocean, all sorts of stuff down there you can take a look at. Nitrogen is a big one, but all sorts of different examples. A lot of ecosystems have various limiting factors, and it's up to us to kind of identify and see which one of them is really limiting our productivity. So next thing I want to talk about, after we're talking about productivity, we need to talk about how this energy, once we've got it, is transferred. So we talked about energy flowing because it can't be created or destroyed, it's just transferring, it's transformed. So one of the ways that it's transformed is through our trophic structures. We talked about that last time, and we're going to talk about how it moves from the sun down to our primary producers, to our consumers, all the way up to our apex predators in our food webs here. And so there's this thing called trophic efficiency, and this is the percentage of the production, the productivity of your environment there, and how much of that is transferred from one trophic level to the next. So how much energy is really transferred from your primary producers to your primary consumers? How much energy is transferred between the consumers then? If you are, say, a carnivore and you eat these primary consumers, how much of that energy are you actually receiving? So if you guys take a look at this chart here, if you guys read right here, it's typically about 10% of the energy is actually transferred. So if we start out with 10,000 joules of energy with our producers, our primary consumers are only going to get about 1,000 joules out of it. If we move up to our secondary consumers, we only get about 100 joules. And all the way up to our tertiary, we get 10 joules. If we had a quaternary consumer, it'll only be 1 joule. So there's a lot of energy that's being lost here. So the question is, where is this going? I mean, it's not stuck somewhere, right? It's not going off into who knows what. It's being transferred to somewhere else. It's flowing into another location. So that's what we have to find out. Where is this going? So most of the energy that gets lost leaves through various types of matter, such as fecal matter, stuff that is decomposed by detritivores. All that stuff is energy that's lost. It's transferred from one level to the next. There's also a lot of energy that goes into reproduction. Being able to reproduce takes a lot of energy. And so all the energy that goes into that is lost from the next trophic level. Right? Any energy that a primary consumer uses is lost to reproduction. And so the secondary consumer there is not going to get as much energy from them as they could have. The last one, and probably one of the more important ones, is respiration. So every time that an organism needs to keep up body heat or is going through these respiratory processes, it's using up energy. And all the energy that does not go to growth for an organism is lost. And a lot of that is lost as heat out to the environment. So we saw in the very initial slide there how all this energy is lost. These are some of the main ways it's lost here. So anything here, like fecal matter, all this stuff, is just energy that's being taken out and is not available for the next trophic level. So that's why this inefficiency is so, is inefficient. The efficiency is very low, only about 10%. So anytime that you're not using something for growth, as it is here, it's going to be lost. So the final point in this, some really important notes for you guys as you're going through and you're thinking about this, you're trying to get these concepts in your head, is that ecosystems are open. So all this energy, whether it's heat, whether it's biomass, whether it's the growth there, all the energy here can flow from one ecosystem to another. They are not closed off. Our whole biosphere has energy flowing from one ecosystem to the next. And not only can the energy flow between ecosystems, it also flows between our trophic levels. So keep in mind when we talk about productivity, when we talk about energy, we talk about respiration, all these different things, the energy is flowing and it's fluctuating all throughout the biosphere as a whole, not only their trophic levels, but their ecosystems as well. So there's all sorts of places this energy is going, and energy transfer is not the most efficient of things. So this is the energy flow portion. We're going to talk about nutrient recycling and all that stuff next. So that's it. Hopefully you guys have some good questions for me. But this is energy flow. Okay? Thanks.